I'm going to assume that you all know at a basic level how Go build works and what Garble is for. But a quick recap, Garble is a code obfuscator for Go builds and code. So it essentially replaces Go build. So you run Garble build, and by pure magic, it just does its thing, right? Um, I do have a few basic ideas here in the README. So the tool is designed to couple with command Go, which is Go build. It's meant to be deterministic. It's also meant to be reversible, but I'm not going to talk about that today. And then it does a bunch of things that help with obfuscation, which boils down to removing information like names or file names and so on. So that's fine so far. On to how it actually works. I tried to write a bit of docs today. So let's see, view file. So this is the contributing doc. It talks a bit about how to contribute and test. But the section that I wrote earlier today is about how Garble integrates into Go builds. So essentially, Go build, when you run it, it loads all the packages that it needs to actually build. So that would be usually a main package and all of its dependencies, but there may not be no main package. And then it will separate that into little steps that it can actually execute. So usually that's running commands like compile or link or asm, which is the assembler. And you can see those if you run go build -x. So that will be essentially like a very verbose list of all the commands that it's supposedly running, even though it doesn't run as a script. And it's important to understand that each one of these tools is executed as a separate process. So for example, a small go build with one main package and one library, if you run go build -x, you might see a tree of processes like this. So you've got the top level go build, and then it spawns the compiler for the library package with its files, the same thing for the main package, and then finally the linker. And Garble build initially started as go build -toolexec equals Garble. And toolexec is essentially a feature of the Go toolchain of the command Go program that lets us man in the middle these executions or wrap them, if you want to think of it that way. So for example, instead of running the compile binary, which is the compiler program with its input, it instead runs Garble, the compiler binary, and then its flags and arguments. So in that specific case, for example, what we do is we parse these Go files, we obfuscate the Go source code, we write the obfuscated source to temporary files, and then feed those modified files to the compiler. So it's sort of transparent in a way. So because of the above, because of what I just said, Garble runs as multiple processes. It's not a single process that does everything, because Go build itself is not a single process that does everything. So you can end up, if we compare this tree of processes with what Garble build sees, you've got the top level Garble build, which technically we don't need. We could have users run go build -toolexec equals Garble. And initially we started that way. But for multiple reasons, one of them being that it's easier, but others such as, we want to do initial setup work as well, or we want to have a nice help UI, that kind of thing. You run Garble build. It then executes go build toolexec. And then, like I said, for each one of these, such as the compile, and link, it will instead run Garble. And then Garble will do stuff, will obfuscate, and then call the real thing. And I should probably clarify that we don't actually pass the same arguments here, but I'll make a mental note for that. And I've made two more notes here. They're not technically needed to understand how Garble works, but I think it helps to understand how the design works internally if you want to make any changes. So Go builds happen one package at a time. And because Garble extends Go builds, it's the same with obfuscation. We only obfuscate one package at a time. As far as Go build works, this is necessary to support build caching and incremental builds. So if you only modify one package, you will need to rebuild that package and its dependents. You don't need to rebuild everything. You don't need to rebuild all of your dependencies. And it also builds packages in parallel whenever it can. And that usually happens whenever they're not blocked by building a dependency. because dependencies need to build before the dependents. And to deduplicate work, the top-level Garble process will also look at the packages that it needs to obfuscate and build. It will save some information about them and then share it with all the Garble subprocesses with a temporary file. So they don't also need to load that information from the raw sources again. Raw sources meaning the Go files, the build cache, and so on. And each Garble subprocess also produces extra cached output of its own. So I should probably clarify what this means here. But essentially, when you run the compiler, it produces a compiled object, right? An object file, and that is its cached output. So then it's consumed by, for example, this compile step or this link step. So Garble does something similar because, for example, this Garble execution here needs to know what declarations were obfuscated in this package. And the way it does that, it could recompute all of that by itself, but that would be very expensive. You can think of a large build with 1,000 packages. You don't want to be recomputing that every single time you need to load a dependency. So instead, that's saved as another cached file. And right now we use gob files, gob encoded files. And then you just encode, save what you need to reuse later, and then just consume it and use it. So I'm going to stop for a minute now and see questions because I saw a couple. Yeah, replace with a name showing it's a temp file. That's a good point. Any questions so far? Does anybody think that this integration section is not very clear?
Seems pretty clear to me. Thank you for putting together the documentation. I've always found that a project is much more fun and easier to work with when it's well documented, as opposed to having to repeatedly, each person involved, relearn everything. So thanks for putting this together.
Sure.
Hey, Daniel, I'm not sure I quite understood the extra cached output. Is that just in whatever format Garble wants it to be, encoded as gob? Or do you have to match the format that the original Go build stages used somehow?
So right now we just use our own files and we encode them however we want. We can also technically put them wherever we want, but right now we put them next to the compiler's output files, which we actually might need to change sooner than later. But essentially, yes, it's files that we control. I'm going to briefly mention the development tips, and then I'm going to move over to the actual code tour, looking at the Go files. The one more tip in terms of understanding how the processes work that's useful is you can use Garble debug build. So debug is a flag that Garble itself takes, and it will print tons of information, such as, for example, I obfuscated the name foobar into this base64 string, or it took me this amount of milliseconds to load the cached files from my dependencies. It's going to print a lot of stuff, but if you want to, for example, debug why, or for example, if you get a build error and it says unknown name and then a base64 hash, and you don't know what that base64 hash came from, you can use the debug flag to then look at the logs and see, oh, that actually corresponds to this name. There's also the debug dir flag, and that output the directory that's sort of like Go path / vendor style, in the sense that it's debug dir / github.com/foo/bar foo.go, and that will give you the obfuscated source code for the build. So these are essentially the same files that get fed to the compiler for each package. It's not equivalent to obtaining those files and then running Go build yourself, because Garble does other things like supply special flags to the compiler or linker. But it's enough if, for example, you want to inspect the source code and see how it was obfuscated. And I also wrote a bit here about how when you're investigating an issue, it's helpful to try to reduce the input build as much as possible. So if building 50 packages fails, the first thing I try to do is try to understand what's failing and then reproduce that as either a single small package or two small packages. And if you do that, then, for example, Garble debug, instead of printing 30 pages of output, it might just print 2 pages of output. Or if you're testing things quickly, the rebuilds might only take like 1 second instead of 10 seconds. So that is very helpful. Cool. I'm going to move on to the code tour. And I'm going to stay on GitHub, even though it might not be the best way to view the code, but I also don't expect to be able to need to do fancy things. So I realize how the main function is not very close to the top. Maybe I should fix that. But essentially, we've got the main function here called from up here, but that's just a wrapper. Some flag setup. Another main function, this one returns an error, because why not? Oh, that's cool. Oh, it refreshes the page. Thank you. This is the top level CLI. So what command am I running? Help, version, reverse, build, test, because it supports, these two are just wrapping go build and go test. And this is for reversing, for example, panic outputs or outputs including names, obfuscating names. I'm going to ignore reverse for now. I'm going to look at Garble build to begin with. So the first thing it does is it says it runs toolexec command, and toolexec cmd does the setup to be able to run go build /toolexec, sorry, -toolexec equals Garble, right? So it filters what build flags it needs to forward. So for example, if you run Garble build -tags equals something, you need to forward that flag to go build. The reason we filter is because some flags, if I recall correctly, shouldn't be forwarded. We fetch information about the Go environment, which we need for some reasons, such as understanding what flags Go build understands. We check that the Go version the user is using is fine. If it's too old, we want to fail and say, hey, we just don't support that because it's going to fail in weird ways. So we want to give a good error. We find what Garble executable we're using because we need to feed that to toolexec. We find our own build ID. The reason for this is because we use that as part of the build cache. So what this is useful for is if Garble changes in any way, then we need to re-obfuscate builds, right? Because the way Garble obfuscates code might have changed. And we can't really rely on Garble's version being useful because up until recently, you could only use versions from tags and so on. Nowadays, Go build also embeds VCS information. We could potentially use that. But for now, we use what is essentially a hash of the binary. So if anything changes in the Garble binary, then we just restart builds from scratch. What this does is it loads the packages to build. And I realize the name append listed packages is maybe not super intuitive, but that is essentially what it does. It runs go list, and go list is just, it's being overloaded a bit by the Go project. Initially, it only listed packages. So you do go list /.. and it just lists all the import paths that match those packages. But nowadays, you can give it the JSON and export flags, and JSON will print information about those packages in the form of a stream of JSON objects. So that includes the package name, package import path, its files, what module it belongs to, and so on. And -export also gives you the compiled object files for each package, which we use later for essentially loading type information for each of these packages. And then we just decode it and save it. Where was I? We save that information in the shared cache. That is the GOP file that I mentioned earlier that the top level Garble process saves, and then other ones can reuse. And then I use an environment variable to then share it with them. So here's, for example, one of the cases where we need to know what version of Go is being used. And this is not the version of Go that builds Garble, but the version of Go that the user is running Go build with. So if it's 118 or after, we supply the build VCS equals false flag, because that was added in 118. 117 doesn't know this flag. And then we do tool exec with our own exec path with all the flags. Append flags. What did this do? Oh yeah, with all of Garble's own flags, so that if you supplied, for example, literals, this is propagated to the Garble subprocesses as well, because the top level parent Garble process doesn't actually do any obfuscation. It just spawns go build tool exec, right? So it needs to pass those flags along. And then we just run, well, we don't actually run go build tool exec yet, but we return the command to do that. And then if we go back to tool exec cmd, and then we run it. So this is the top level Garble command finished. Any questions up to this point? And I'm gonna mute myself for like 20 seconds. Cool. So then the next step is, what about when Garble gets executed as one of those subprocesses that wraps the compiler or the linker, right? So it will fail to enter into any of these cases because the first argument, instead of being like help or build, it will be an absolute path to a program from the Go toolchain, such as the compiler. So if it's not an absolute path, we essentially freak out and say, we don't know what this command is, because most likely somebody ran garble foo, which doesn't exist. We load the shared cache, which we talked about earlier. It contains the information about all the packages to build. This probably deserves documentation. This is to wrap the feature in the Go compiler binary that tells Go build what version it is. And the reason this is useful is for the same reason that I earlier explained, the thing about build IDs, which is that if you update from Go 117 to Go 117.1, for example, and you run Go build and your cache is warm with the older version, Go build needs to understand that it cannot reuse those build cache entries, right? It needs to rebuild all the packages, essentially all the packages, because the Go version has changed. And the way it currently does that is the compiler contains a full version string. And I can't really share that right now because I'm sharing a tab, but I can share that later. And that essentially shows a hash of the compiler binary. But it also changes if I guess it only changes if the compiler changes, which is fine. So essentially what we want to do here is, when Go build is asking, do I need to rebuild any packages, i.e., has the toolchain version changed? It's not enough if the Go compiler has changed. We also want the rebuilds to happen if the Garble version changed. And the way we do that is by inserting Garble's version into the compiler's version. So we essentially join the two, so that if any of the two changes, then builds need to be redone. Did I explain that properly? I'm going to hope so. If anybody got lost, please interrupt me. But essentially, I'm not going to explain what this code does, but it essentially takes the output of the compiler's v equals full flag, which is in a format resembling this. It essentially does build ID equals, and then it's like a very long hash. So then we say, okay, yeah, that's fine, but we add our own binary hash to that hash to create a new hash and then print that. And we print it in a sort of hacky format, but it works. Any questions up to this point?
So is that build ID unique to like different builds of different packages, or is that unique to like the Go version and Garble version?
It's only unique to the Go version and Garble version.
Okay, cool. So that's basically trying to avoid the case where you've generated some cached files that aren't compatible.
Yeah.
Is that right? Yeah.
Yeah, so for example, if you make one change to Garble that changes how the obfuscation is done, and you didn't have this, where was it? If you didn't have this call, then what would happen is that Garble build would reuse the previous cached compiled files from the previous Garble build, and you would essentially not see the change in obfuscation take place, right, in your new build.
Yeah, got it.
So I think this needs a bit of docs to explain that this is just about the versioning of the Go toolchain and Garble to make sure the Go cache is only reused when the versions are exactly the same. So then we get into the actual execution of Garble with the compiler or linker. So now we're wrapping one of these tools with toolexec. So there's an environment variable called toolexec import path, and that tells tools that use toolexec, hey, right now you're wrapping an execution of a tool to build this program, given its import path. So from the shared cache, we look up what package that is, and that's going to tell us, for example, what its directory is or what its package name is. We fail if that fails, because it shouldn't fail. And then we've got a bunch of transform functions, and the transform functions, oh, Jesus. We essentially only transform 3 commands. The compiler to obfuscate Go code, but the assembler, even though we don't obfuscate assembly, we still need to handle it because the assembly can refer to Go function names, so we need to fix those up. And the linker, because we want to pass some extra flags to the linker. So if we're not transforming the tool, such as, for example, one of the tools is called build ID, and all it does is it just embeds build ID strings into cached files, and Go needs that, but we don't care. So for these, we just let it go through normally. But for the compiler, assembler, and linker, we call the transform function. And the transform function, it takes the list of arguments, returns a new list of arguments with an error, and then we just call the tool with the transformed list of arguments. And I'm trying to think which of the 3 is the easiest to start with. I think the linker is the easiest because the linker is what does the least. So transform link. So from the arguments, we split the flags. We process a file called import config, and that is it's a plain so the import config flag points to a file, and that plain text file tells you where the object files for your dependencies are. So if we go if we look at this again, compiling the main package, which depends on the library package, it needs to load the object file for the library package because it needs to know how to compile with it. So we could actually add this here. the compiler invocation for the main package would include an import config flag, and the import config file would say, hey, I've got a package file for this import path at this path on disk, and the path on disk will be a path inside the build cache with the build object file. And the build object file is just an archive file, just like in C or C++ or any other language. Go's export object format is different, but at the end of the day, it's the same purpose. And I just realized I'm sharing one tab, so I didn't show anything. Let me try that again. So I was looking at this. So I said, when you build the main package, you need to load the object file for the library because it's a dependency. So this command here would include an import config flag with the contents that I just explained. Transform link. And the reason we need that, why did we need that? Oh, yes. One of the reasons we need that is actually kind of silly. It's because the format of the import config flag is like, you have import config equals path to config. And then the file actually contains something like package file github.com foo bar library equals home u go build cache. Some hash.a. I think so. Essentially, what happens is because we're obfuscating package import paths, the Go toolchain will not know what this means because we replace github.com foo bar library with some 8-digit hash. So we need to actually fix that up so that the import config file that gets fed to the real tool actually contains whatever hash it is here. Because the way we obfuscate import paths is that we do it right from the start. We replace all the flags, we replace all the references and import statements and so on. So any more questions up to this point?
Yes, a very short one to know if this is part of how we can. Let me explain it. Is this part of how we can use the seed for compiling some other projects that can reuse the seed? They can talk with an obfuscated program, or is this going to come later in your summary?
I mean, everything is related, but I don't think anything I've mentioned so far relates to the seeds.
Okay.
I've actually talked in a little bit too much detail, maybe. So I want to wrap up soon before I bore you all to death. So let me just finish by saying that transform link does a bunch more things, like it iterates over the X flags, which you can use to embed strings into a build binary. So you can say the version equals 1.2.3. And what we do is, if that name was obfuscated, we replace the flag. So that's one of the things that transform does. We also hide the runtime's build version. We also hide the build ID for the entire binary. And we also make sure that the binary is stripped. And we pass the new import config file to the linker. And that is it. And obviously, if you look at transform compile, it does quite a lot more because it needs to, actually parse the files. It needs to then look at each one of the files, obfuscate them, which is transform go. It needs to print them back out into temporary files, which is this, and then it needs to actually pass them along. So the compiler's transformation is quite a bit more tricky, but at the end of the day, it's still the same. It's just replacing the arguments. And I think I'm going to shut up for now, and you all tell me what I should talk about more. The seeds, the obfuscation of Go code, the caching, the performance. I'm happy to go into any direction.
I actually do have one question. I would be interested in hearing more about how the actual obfuscation of the code works, because that's kind of the crux of the biscuit. But on the way through the linker, I am curious. So you mentioned that you were modifying the build ID to have to also be hashed with the Garble version. I'm wondering if that is the build ID that ends up in the final binary, or if you're doing something different with the build ID that goes into the binary.
That's a good question. I actually don't like the term build ID because it's quite confusing. A build ID is just a hash that gets used by the build cache and gets embedded into binaries. At the basic level, it's just a hash of either a build action that you want to do. So it can be the hash of all the Go files to compile for a package, or it can also, one sec, sorry. Or it can also be the hash of the result of a build step, such as linking a binary of results in a binary, and then if you hash that binary, that's also a build ID, and that gets embedded into the binary. So when you have v full, when you run go tool compile v equals full, it essentially just prints its own output build ID, which is the hash of its own binary. But then at a different level, when we're linking a binary as part of Garble build, Go build also wants the linker to embed that binary's build ID in the result, right? And we don't want that to happen because it's just another bit of information that gets leaked. So we essentially hide that. But they're two separate build IDs, even though conceptually they're the same. One is a build ID that we use from the toolchain. The other one is the one we're producing.
So just one note, having a blank build ID set in a Go binary is something that some EDRs flag as a signal. So it would be nice to just set that to a completely random number, or at least have that as an option, rather than just blanking it out. But just a comment.
Yeah, that's a good point, actually. I'm not sure to what degree trying to hide the fact that we're obfuscating is a good idea, because we are obfuscating, but at the same time, doing things that gives it away that something is not like a proper Go build might not be the best idea. So
it's not about hiding that you're obfuscating. It's about just not matching whatever signature they entered into their database.
Yeah, okay. So I guess we can avoid the easy ones, such as the build ID doesn't exist. I guess we could do the same with like the runtime version, even though I'm not sure what I would replace it with. Okay, just took some notes so I actually remember these things. And then you asked about the actual obfuscation of Go code. So we obfuscate at the AST level right now, which means we obfuscate Go syntax. We don't obfuscate anything fancy like an internal representation of the code or anything like that. We could talk about why that is later, but I'm going to omit that for now. We do something that I mentioned earlier is that we replace the package paths, and you can see that happening here. So there's a P flag that says you're compiling a package with import path this, so we've replaced that. So transform go. So we actually need two things to properly obfuscate Go code. Obviously, having the AST is one thing, and we parse the files here. So for all the paths that we're compiling, we parse them, collect them. But then having the syntax tree is not enough, because the syntax tree is enough to, for example, reformat the code. But if you want to analyze it in any useful way, you also need to have the type information, such as, if you do foo.bar, what is foo and what is bar? If you want to know what those names refer to, usually you use a type checker for that. So we do call the type checker, and that is go/types, whereas the AST is go/AST. They're both packages in the standard library. Um, and so if we're compiling, for example, the main package that imports the library package, the type checker also needs to load information about the library package. So the way it obtains that is from the export files that we loaded initially with the shared cache file. So these will also be entries in the build cache. And and something that's important to note is that we load the type information for the original packages, not the obfuscated packages, because we need to understand the program as it is originally so that we can understand how to obfuscate it. But we obviously don't have the obfuscated type information before we obfuscate anything. So type check. So once we have the AST and the type information, we call transform go. And transform go started as a pretty short function. At this point, it's a monster, and we should probably try to break it up. But it essentially runs apply over the file, and apply is an API that lets you walk a syntax tree, and it lets you run a pre and a post function, meaning that as you do the walk, which I think is depth first search, it lets you run a function on each node before you walk it and after you walk it. So the pre is what does most of the work. It wants to find all the identifiers, as in all the names. It wants to omit names such as underscore. It loads what object each name is with the type information, and that is useful to know if that is a definition of a name, if that is using a defined name, if that is a name that comes from another package, or if it's your own name, and so on. I'm going to ignore this for now. There's just details. There's some other special cases here, like, for example, if the type checker said that the package is nil, that means that this name is in the universe scope. It's a built-in name. So then we don't obfuscate it because we can't. If the package is embed, we also don't obfuscate anything because that just breaks embedding. We load the package with the information that we share, and then this is where the actual obfuscation happens. So what kind of object are we obfuscating? Is it a variable? Is it a type name? Is it a function name? So for example, functions, main, init, and test main cannot be obfuscated because the names are hard-coded to be those. Similarly, for variables, for some fields, we want to be careful with how we obfuscate them because we don't want to break conversion between struct types. And type names are always obfuscated because why not? And then here's where the magic happens, at least for names. So we replace the name of the identifier with hash with package. And hash with package says, wait. where do I declare LPKG? Oh, yeah, there we go. So we looked up what package owns this name, which might not be the package we're currently obfuscating, because if you import package library and then use the name that it exports, like library.foo, then package.path here will be library. It will not be main. It will not be yourself. So what we do is we hash the original name foo with the package that it came from. And the reason we include the package here is because we could obfuscate all the names the same across the entire build, but then that wouldn't be as useful if, for example, a name foo was obfuscated the same way in all the packages, right? I think you could potentially run into conflicts as well, because in Go, scopes are for each package. And the way hash with package works, it's a bit complicated these days because we made C deterministic, and that's in a different file. But let's just assume that we're not using a custom seed. So we hash the name with a salt, as in just another part of the hash. That is what I called the Garble action ID for that package, and that is another hash, and it's a hash of that package's build ID and Garble's build ID. And the reason that's useful is because, again, just like before, if the package in question changes in any way, then its obfuscation changes completely. And if the version of Garble changes in any way, then the obfuscation also changes completely. And then if the user supplied a custom seed, we assume that they don't want the obfuscation to change dramatically with any of these factors. They want to just control that with the seed, with the static seed that they provide. So then we just hash with the package's import path, which in general is pretty stable, and the name. And the last thing that I'm going to show is what hash with custom salt does. It just uses a hasher, which is it's SHA-256 right now. I'm thinking of changing that to Blake2B at some point, but I'm not in a hurry. So we write the salt, which again is either some build IDs that change if anything changes, or the seed that the user provided. No, sorry, the salt is either, it's one of these two, right? It's either the build ID that I mentioned, or just the import path, the seed that the user provided, which might be empty or it might be random, and then just the name that we're obfuscating. And then we sum that, we get the hash, we encode it into base 64, and we have to be careful because a usual base 64 char set includes characters like dashes or slashes, which are not valid for Go names. So all of this is pretty normal base 64, A to Z, 0 to 9, an underscore, which are all okay for Go names. But then I repeat Z because I'm missing one letter in ASCII. And then the only thing more to do is if we were unlucky enough that the first character is a digit, then we need to replace that with a letter, because Go names can start with digits. And that is pretty much it. We also do the same if we ended up with an identifier, which should never happen, but why not check? And there's a bit of docs here about how we ended up at a length of 8 with base 64. And essentially it's because we used to use 6, and it was relatively likely that you would end up in a collision if you compiled a package that was large enough. And I think that's enough talking for today. Any more questions? Anything else you guys want me to talk about?
So I saw a list of, well, various to-do items and comments as you were scrolling through the code. Is there any desire to consolidate those to-dos in a centralized place to allow folks interested in contributing kind of the opportunity to go and see here's our desired contributions and then pick one and run with it.
Yeah, that's a good question. There are a bunch of to-dos. In general, the to-dos are either things that I wrote for myself, and they're not really up for grabs, if that makes sense, because they tend to not be easy things.
Mm-hmm.
Some other to-dos are relatively easy, like, hey, just a reminder to bump this to 118 once static check supports 118. Or
Mm-hmm.
like, for example, we've got a test that makes sure that we support assembly, and I was only bothered enough to write the assembly in x86. So if anybody knows ARM assembly and can double check that we support, multiple assembly languages, that's up for grabs. But in general, I do use the issue tracker for things that are more approachable. And the label good first issue is one to look for.
Okay. Cool. Thanks.
There's not a lot of them right now, but I think there were more in the past. Or maybe not. Maybe I haven't been super diligent with that. Yeah, I haven't been very diligent with that. I'll try to label a few more.
I had a question on limitations and things that you are aware of in terms of limitations of usage of Garble and potentially sort of leading into ways that Garble could be improved.
So I think there's two kinds of limitations currently. One is limitations that we can't really get over easily because they're just part of the design, such as I don't think obfuscation is going to be more than just obfuscating the AST, the syntax tree, for the foreseeable future. And that is just because the Go toolchain doesn't have an internal representation of programs that's lower level or more advanced, further along the compilation steps. It does have an internal SSA step, but that is not exposed in any way. We could fork the compiler, and we could talk about that, but that is wildly complex. So it's not something I'm looking to do right now. There's a bunch of other limitations that are within reach. We just haven't had enough time for them. There's a bunch of caveats here for things that are major, I think. So for example, exported methods are never obfuscated right now. We certainly could. It's just that we have to worry about interfaces, right? So we do have this issue. And I think we're going to be able to do this, for example, as soon as we can obfuscate all the packages. Right now, we can't obfuscate the runtime. And if you can't obfuscate the runtime and some of the standard library, then you have interfaces like Stringer or like io.reader, where you can't obfuscate those method names, and then you can't obfuscate exported method names. So if you can obfuscate all the interfaces, then in theory, you can obfuscate all the method names, as long as you're careful that the obfuscation is the same for all the packages, right? We also don't support Go plugins, even though Go plugins don't really work anyway, so I'm not really bothered. And there's a bunch of stuff here on the issues. I think if you sort by upvotes, I already mentioned obfuscating the runtime package. I think another major limitation right now is that we don't really obfuscate function bodies very well. We do replace names and we hide position information, but otherwise the code is compiled the same. So if you deobfuscate some code, you could still see the structure or what it's trying to do. So I would say this is one of the major to-do items in terms of quality of obfuscation. Any more questions? Anything else we should cover?
I'm curious, why did you start Garble? I'm guessing a lot of us are here from like an offensive security tooling standpoint, but why did you, or at least that's why I'm here. Won't speak for anyone else, but why did you start Garble in the first place?
So my background isn't in like security or offensive software or anything like that. My background is pretty generally in open source and Go. But I do have one friend that wrote an application in Go for Android, and he was trying to be sneaky about what the app actually did under the hood. So he was manually obfuscating the Go code, as in manually using garbage function names, or like manually adding like useless code to try to make sure that it was less obvious. And I was just horrified by that. And I thought, well, surely there's some way to do this automatically. Um, and it's something that they say that the first step towards doing something difficult is greatly underestimating how difficult it is, right? So I thought, well, I know that Go build has this flag called toolexec because I had used it before for like toy things. So I said, I'm sure I can write one that wraps the compiler and just replaces names with hashes. And that was the very first version, which actually wasn't too complicated. It was like 200 lines of Go code. But then obviously many programs would fail to obfuscate, and then slowly and slowly it became quite a bit more complex.
I'm curious if existing tools, most of the obfuscation tools I've seen are for C# assemblies. So there's like one called Invisibility Cloak, or there's a couple of other obfuscation projects that are C# specific, but could be useful in just determining obfuscation strategies. And I'm not sure if they would be as applicable to Go as C#, but that might be a resource to look into.
Yeah, I think Go sits at a bit of a weird place, because I think obfuscating some languages is significantly easier if they lack features like reflection, or like open-ended interfaces. Like for example, in Java, you do have to explicitly say what interfaces you implement, and then static analysis, as in, what interfaces is this method implementing, is pretty easy. But in Go, because it's completely open-ended, it is quite a bit more difficult to deal with some of these situations. On the other hand, I think Go has an advantage over some other languages in that it compiles much faster, and the tool chain is a lot easier than, for example, LLVM. So I think we can probably borrow ideas from other projects. I'm trying to do that now with the obfuscation of function bodies. I haven't tried to do that so much with the other parts of how Garble works, just because I'm not sure that I can borrow many useful ideas beyond just try to remove information. But I think if any of you know of tactics that other obfuscators use that could translate well to Go or to Garble, I'm happy to hear ideas.
So we were talking about doing some control flow obfuscation. So now that I sort of understand what you're doing with the AST utility, does the AST util let you do transformations, or is it really like on the AST itself, or is it really just like something that lets you walk the tree and maybe change attributes of tree nodes, but you'd have a difficult time like rearranging big chunks of the tree?
It does let you replace chunks of the AST entirely, so yeah, definitely. So here it is. So you get a cursor for each position you're in, and you can just replace a node with an entirely different node. You can also insert before, after, delete, and so on. what I intend to do with control flow obfuscation, which is this I called it obfuscate function bodies, which is maybe not the best issue name, but in Go, you only have control flow inside function bodies. So I think it's reasonable. My idea is we could do this at the AST level alone, but it would be kind of difficult because the Go AST can, it has lots of ways to represent the same code, right? You can have, you can declare a variable in like 5 different ways. You can have switches in multiple different ways. You can have selects and channel sends and receives in multiple different ways. So we could do it with the syntax tree alone, but it would be a lot of code, I think. And it would also be quite complex and probably not very useful unless we actually spend a ton of time on it. So the idea is, the Go compiler does use an SSA form, which is a sort of lower level static single assignment form. And that is still a form of tree representing the program, but it's much lower level. It doesn't understand switches, for example. It only has like comparisons and branches. So if you're trying to understand what a program does, using the SSA form means that you can understand what the program does by only understanding like 12 different kinds of nodes as opposed to like 50. So the idea is that if we do the control flow obfuscation at the SSA level, it's going to be significantly more powerful because it's at a further along stage of compilation. It's at a lower level than the syntax tree. But the disadvantage is that the Go compiler consumes Go code. It consumes syntax. It doesn't consume SSA. Even though it internally uses SSA, it doesn't accept that as input. So my current thinking is to compile the syntax to SSA with this package, golang.org/x/tool/go/SSA. And that is just like a public stable version implementation of SSA, quite similar to the compilers, but not the same. And then do some transformations on that, like reshuffle the code, add dummy code, stuff like that. And then reproduce Go code from the SSA. So the Go code will look extremely janky if you do this. So, for example, imagine that you have a switch, right? Switch X equals Y. Imagine if you have this. The SSA will look something like, declare X equals Y. If X equals Z, then go to blah, 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 and then like some other SSA operations here. So it's sort of like a, don't think of it as assembly. It's just an internal representation that's single assignment, but it is a lot simpler, a lot lower level. So if you think of what kind of Go code we could reconstruct from this, you could think of like X equals Y, if X equals Z, then dot else if, and then the other switch cases. But the cool thing is that because this is a lot simpler, we can then introduce junk here, and then it would show up here when we reconstruct the Go AST. And I'm fairly sure that all the SSA can be reconstructed as Go code because both are Turing complete. They're both full programming languages, and the SSA does support things like send to a channel or call a function, so it should be possible. I'm a little worried about how bad this kind of retrofitted Go code will look like, but at the end of the day, if it's just obfuscated code, I don't think it really matters. Cool. I think I've definitely talked to enough for today. So any last question? And I think my thinking is that 1 hour is enough for today, but if this was useful, we should probably set up another one, maybe in like a week or a couple of weeks. And in a follow-up one, we could talk about how the tool is deterministic. We could talk about performance. We could talk about assembly. We could talk about linking. There's like a dozen topics we could get into.